So one reason we talk about limits is because it helps us to prove continuity. So for the definition of continuity, in order to say that a function is continuous, we need three things to be true. The first thing that has to be true is f of c has to exist, right? There has to be a solid dot at that point. The limit as x approaches c of f of x has to exist, meaning that the left and the right side of the function are both approaching the same y value. And the third thing that has to happen is that the limit has to also equal the function value. Right? So a continuous function, right? We know what continuous functions look like, right? Our basic definition is that, right, if you can draw the function without having to pick up your pencil, right? So a polynomial is a great example. Right? So here we would have the function is defined at c, right? F of c exists, right? The limit is approaching the point and the limit is equal to the point, right? Very straightforward, easy case. So what are some functions that are not continuous? Right, so some examples of where one of these conditions is going to fail. Okay, right? So we're not going to draw, of course, like all of the different variations, but some things to be careful of, right? So f of c could exist. So maybe we make c here. So f of c exists. Right? Right? The limit there exists, but the limit is not equal to the point, right? So in this case, we have that the limit as x approaches c of f of x does not equal f of c, right? And another easy way to do this is just to say, well, f of c does not exist. Right? Just some things to be careful of. And then we can also say, right, f of c exists, but now the limit no longer exists at that point. So just some things that be aware of. So with continuity, what we can do is we're going to use that definition to determine if a function is continuous. Now, of course, you could graph it and probably see with your eyes, but one thing that College Board and that what we want to do in AP Calculus is really show beyond a shadow of a doubt that we understand the math behind why we know stuff is true, right? So you might be able to say, like, yeah, I know it's going to be continuous there or not continuous there, but can you provide a solid mathematical argument for why you know that, not versus like, I can just see it. So we're going to prove it's continuous at 2 and negative 2. So let's start with x equaling 2. So the first condition we always want to check is, does f of 2 exist? So f of 2 is going to be in that middle branch, so it's going to be 2 squared over 2. So 4 over 2 is 2. Okay, so f of 2 exists. Okay, so now we got to figure out the limit as x approaches 2. So because this is a piecewise function and we have 2 is at an endpoint, I need to evaluate the limit from the left and the right. So if I approach from the left, to the left of 2 would put me in that middle branch. Right, so if I approach 2 from the left, I'm going to also get 2. Right here I can just plug in 2. And now if I approach it from the right, that's going to put me down in the bottom branch. And that's just taking the limit as x approaches 2 of 2, so that's going to equal 2. So because our limit equals our function value, right, if you want, you can write it out like this. Right, we can say that the function is continuous. Right, so I guess I can just write that over here, right? Since f of 2 exists, the limit as x approaches 2 exists, right, and the limit is equal to the function value, f of x is continuous at x equaling 2. Right, so now let's test out negative 2. right? So the first thing we're going to find is the function value. So at negative 2, that's going to still put me in that middle branch. So I'm going to get negative 2 squared over 2, which is going to give me back my 2. And then I want to take the limit as x approaches to negative 2 of the function. And again, since it's piecewise and that's a breaking point between the pieces, I want to evaluate the left and the right-hand limit. So let's start with the left. So if I'm on the left of negative 2, that's going to put me in the top branch. So instead of writing f of x, I guess I should write x plus 2 here. Now if I plug in negative 2 plus 2 is going to give me 0. So overall, right, I already know the function is not continuous because the left-hand limit does not match the function value. But we might as well finish off what we started. Now, I know that the limit from the right is going to equal the same thing because that's going to put me into the branch where I evaluated f of negative 2. Right, so we can say that f of x is not continuous at x equaling negative 2. Right? Because the limit as x approaches negative 2 of f of x does not exist. So that fails the second condition. It also technically fails the third condition because since the limit doesn't exist, it can't possibly equal the function value either. So one type of question that they like to throw at you is to use the definition of continuity to find missing coefficient values. So one thing to pay attention to for this piecewise function is that our only break is happening at negative 1. So we know for the function to be continuous at negative 1, right, the function value has to exist. So f of negative 1, which does exist, it's at 4. And then the limit has to equal that same value. Right, the limit has to exist and has to equal the same number. So that helps us out. So because this is a piecewise function, to evaluate that overall limit, we have to take the limit from the left and the right. So if I take the limit from the left of f of x, that's going to put us into that top branch that's a times negative 1 squared minus b. So that's going to be a minus b. And then the limit from the right is going to put us into the bottom one. So that's going to be 2a times negative 1 plus b. So that's going to be negative 2a plus b. Okay, so then we're going to get that because the left and the right limits, right, they have to equal the same number to give us a general limit, and they have to equal the same number that we want the overall limit to be. So they must both be equal to 4. So that means that a minus b equals 4, and negative 2a plus b equals 4. So you have a system of equations now, so you can use substitution, elimination. You could graph them, I guess. That seems like a lot of work. I'm going to use elimination here. So if I add my two equations together, I get a minus 2a is negative a, and then negative b plus b cancels out, and that's going to equal 8. So my a value is going to give me negative 8. And then that means that I can plug that in. So that means negative 8 minus b should equal 4. So if I add the 8 over, I get b is going to equal negative 12. So we can say for f of x to be continuous, a needs to equal negative 8 and b